Hello, my name is Desmond Edagese, and I'm here to take us on the subject mathematics. Today we'll be looking at the theme numbers and numeration. And under numbers and numeration, we'll be learning all about sets. Our topic for today, however, is the properties of sets. Now, sets has certain properties, and one of those properties is cardinality. So in our class for today, we'll be learning all about the cardinality of sets. We'll also learn about another property of sets, which is called complement. Again, we'll be learning about the complement of sets. Let's go into our class. The cardinal number of a set is the number of unique elements that are in the set. In other words, the cardinality of a set is the number of elements found in that set. Now, there are symbols used to represent or denote sets. One of those symbols is your hashtag and P, for instance, if P is our set, or a bar and P followed by a bar. Or better yet still, the more popular option is N standing for the number and our set within a bracket. So this stands for the number of elements within the set P. Let's take a typical example so we understand exactly what cardinality is. If P is a set that has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, the cardinality of our set P is, again we write our symbol, the count of the unique elements within our set P. Remember in our class before now, we said there are no repetitions when doing a count. So, in case we have maybe 2 repeated twice, we'll take it once. That's what we mean by the word unique. Every element is different from the next element. So let's do our count quickly. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and of course 10. We have 10 elements within our set. Therefore, our cardinality here is 10. And that's how simple it is. But before we go on, let's quickly take note of some facts. The cardinal number or the cardinality of a null set is 0. In our class before now, we learned that a null set is also known as an empty set. And an empty set, of course, has no elements within it. So, of course, if we do the count, we'll have 0. So the cardinality of a null set is 0. Take note. Also, the cardinal number or the cardinality of an infinite set is not defined. Or we say is undefined. Reason being that the count of the number of elements within that set is infinite. It cannot be counted. We said it goes on and on and on. Therefore, we cannot actually find the cardinal number or the cardinality of an infinite set. So we say it's undefined or is not defined. Finally, the cardinal number or the cardinality of a singleton set is what? 1. Also in our class where we learned about the different types of sets, we said a single set or a singleton set is a set that has just one element within it. So if we did a count, of course, we'll have just 1. So the cardinal number again of a singleton set is 1. Let's go on. Now let's take some examples to further illustrate all we've learned so far. If we were asked to complete the following, if X is the set that has elements D, T, H, B, S, Q, O, and P, and we're asked to find the cardinality or the cardinal number of our set X, of course we write out our symbol in such a manner, and we'll do a quick count. Let's do it together. We have 1 element, 2, 3, 4, 5, 6, 7, 8. Our cardinal number for the set X is what? 8. Let's try our second example here. If F is the set of the fingers on your hand, here's your hands. If we count the fingers on our hand, how many would you have? You have 1, 2, 3, 4, 5. Therefore, the cardinal number of our set F here is written again in this manner, and our count will be 5. Let's take a look at another example. If A is the set that has elements R, Y, U, and D, B is the set that has elements A, T, N, and U, C is the set that has elements P, M, V, X, S, and E, while D is the set that has elements Z, G, T, O, and Y. State if the following is true. We've been asked to confirm if the cardinality of A is equal to the cardinality of D. For these two cardinal numbers to be equal, of course, they would have to have the same numbers of elements within their set. So we have to do a quick count of the number of elements in our set A and a quick count of the number of elements in our set D. Let's do that quickly. The number of elements in set A is 1 element, 2, 3, 4. So the number or the cardinal number of set A is what? 4. Let's do that for D also. The cardinal number of our set D is what? 1, 2, 3, 4, 5. The cardinal number for our set D is 5. It therefore means that our statement here is obviously wrong. Let's take a look at the next one. The cardinal number of set D is 5. Is that true or false? It is true. We just did a count and we have 5. So this is true. Let's take a look at our second example here. If A is the set that has elements R, Y, U, and D, and B is the set that has elements A, T, N, U, C is the set that has elements P, M, V, X, S, and E, while D is the set that has elements Z, G, T, O, and Y. State if the following is true or false. The cardinality of A is equal to the cardinality of B. We need to confirm if this is true by doing a count of the number of elements in A and doing the same for B. Let's quickly do a count for the number of elements in A. That would be 1 element, 2, 3, 4. If we did a count for the number of elements in B, we would have 1, 2, 3, and 4. It therefore means that our statement here is very much correct. Let's take a look at the other one. The cardinality of the set C is 5. To do that, we need to confirm from our set here. Let's do a count quickly. Cardinality of C is 1 element, 2, 3, 4, 5, 6. So again, this statement is obviously wrong because we have 6 elements within the set C. Let's take a look at our final example. Complete the following. If the set G is the set of whole numbers between 3 and 13, find the cardinal number of G. We will need to write out the list of our set here. To list our set, we would list numbers that are between 3 and 13. It means that the boundary of our numbers are excluded in our list. So we'll not have 3 in our list and we'll not have 13 in our list. So we'll have numbers beginning from 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let's do a count of the number of elements within our set G. We have 1 element, 2, 3, 4, 5, 6, 7, 8, 9. The cardinality of G is 9. Let's take a look at this other one here. If we have a set Z that has as its element O, O of course is considered to be an element, so we have 1 element within our set. It therefore means that the cardinality of the set Z is simply 1. This is a singleton set if you remember. Let's go on. Another property that we have in sets is what is referred to as the complement. The complement of a set is the set that contains all the elements of the universe which are not in the elements of our given set. The symbol used to denote a complement is a prime or a superscript of the letter C that comes after our set. So for instance, our symbols here, the prime and the complement C subscript, is placed after our set name. So this means, for instance, the complement of the set P. Or we may use this method to also denote the complement of the set P. Let's take a typical example. If P is the set that has numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, while we have a universe that has set X such that X ranges from 1 to 20, and X of course is an integer. If we listed all of the elements of X, we'll have 1, 2, 3, 4, 5, 6, 7, up onto 20. The complement, therefore, of our set P, which is P prime or P to the power of our small letter C, is the number of elements that are in the universe, which we've listed as 1, 2, 3, up onto 20, less the number of elements that are in our given set P. That is, again, the elements that are in our universal set, which we've already listed as 1, 2, 3, a count up onto 20, that are not in our given set P. So we have numbers 1 to 10, which is inclusive in our universal set 1 to 20, but the elements from 11 up onto 20 are not in our given set. Our given set, of course, stops at 10, but the universal set continues up onto 20. Therefore, the complement of our set P is the set that has elements within the universe that are not in our given set. And those elements are 11, 12, 13, 14, 15, 16, 17, 18, 19, and of course 20. And this, therefore, is the complement of our set P. Let's go on. Let's take a look at some examples so we better understand what a complement is. If we're given a universal set that has elements 1, 2, 3, 4, 6, and 8, and we're asked to write down the complement of the following sets. Let's take the following sets one after the other. So we have a set that has elements 1, 2, and 3. Let's name our set X. We've been asked to find the complement of X, where our universe has this elements 1, 2, 3, 4, 6, and 8. The complement of our set X, therefore, would be a set that has elements within the universe that are not in our given set. What are those elements? We do a quick comparison and we find that 1, 2, 3, 1, 2, 3 is a common or are common elements between our sets. The elements, that are not common are 4, 6, and 8. It therefore means that our complement will be a set that has the elements 4, 6, and 8. The complement of our set X there is the set that has elements 4, 6, and 8. Let's take our second problem here. Let's also name this set P. The complement of our set P would be a set, again, that has elements present in the universe that are not in our given set. Let's do a quick comparison. We have 1, which is common, 3 is also common, 6 is common, and 8 is common. Therefore, the elements present in our universal set that are not in our given set are 2, 4. 2 and 4 are the elements that are present in the universe and not present in our given set. Therefore, the complement of our given set, which we named as P, is the set that has elements 2 and 4. Again, let's have a go at our problem here. We have a set that has elements 2 and 4, and we've been asked to find the complement of that set. Let's name the set again as N. The complement of N would be a set that has elements present in the universe and not present in our given set. If we did a quick comparison, to take out our common sets, we have 2 and 4, and therefore the elements in the universe not in our given set are 1, 3, 6, and 8. And our complement, the complement of N, is a set that has elements 1, 3, 6, and 8. Lastly, let's try to solve our problem here. To find the complement of our set here, let's quickly name that set as O. So the complement of O would be a set that has the element again present in our universe and not present in our given set. If we compared, we have 1, 2, 3, 4, 6, and 8 in our given set, which are also all present in the universe. But the universe has one set that is not present in our given set. But the universe has one element that is not present in our given set, and that element is 8. It therefore means that the complement of our set, which we named as O, is the set that has element 8. It's a single set or a singleton. Let's take a look at another example here. Again, if we have a universal set with elements A, B, C, D, and E, and we have a set A that has elements A, C, and E. If we also have a given set B with elements B and E, we've been asked to list the members of our set here, which is A prime, and our set here, which is B prime. Let's take them one after the other. The set A prime would be a set that has elements present in our universe here that are not present in our given set A here. Let's do a quick comparison between both sets. So the set A has elements A, C, and E, while our universe has sets A, B, C, D, and E. The elements present within the universe not found in our set A are B and D. So we list them within our derived set. The complement of the set A is simply a set, therefore, that has elements B and D. Again, let's take a look at our next problem here. We've been asked to find the complement of the set B. The complement of the set B is a set that has elements present in our universe here, but not present in our set B. If we compare both elements, we'll find that the set B has element B and E, while the universe has elements A, B, C, D, E. Therefore, the elements in our universe not present in the set B are A, C, and D. And there we have our complement. The complement of B is the set that has elements A, C, and D. Let's take a look also at this example. If we have a universal set that has elements of numbers 1, 2, 3, 4, 5, and it goes on to 10, while we have a set A that has elements of numbers 1, 2, 5, and 7. If the set B given has also elements of numbers 1, 3, 6, and 7, we've been asked to write down the sets of A prime. That is the complement of A and also the complement of B. Let's take them one after the other. The complement of A would be a set that contains the elements present in our universe that are not found in the set A. Let's quickly compare the elements of both sets. So our set A has elements 1, 2, 5, and 7, while our universe has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The elements, therefore, in our universe, not in A, are 3, 4, 6, 8, 9, and 10. And there we have our complement, the complement of A, or the A prime. Let's also find the complement of B. Again, the complement of B is the elements of our universal set not present in our set B. To do a quick comparison, we'll find that our set B has elements 1, 3, 6, and 7, while our universe has elements 1, 2, 3, up onto 10. So if we compared both sets, we'll find that the elements in our universe that are not in the set B are 2, 4, 5, 8, 9, and 10. Again, there we have our complement. Let's take a look at our final problem here. If we have a universal set that is the set of all days of the week, and we have a set S that is the set of days which contain the letter S, while we have the set N, which is a set of days which contains 6 letters. List the members of the set. So we've been asked to list the members of S prime, that is the complement of the set S. We've also been asked to list the members of the set N prime, and that is the complement of the set N. To do this, we would have to list our universal set. That list would be a set that has the days Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we have the list of our universe here. Now let's try to also list our set S. S is the set of days that contain the letter S. So S would be a set that has members. Let's look at our universe here and see any of the days listed that has the letter S within it. So we have Tuesday, we have Wednesday, we have Thursday, we have Saturday, and we have Sunday. Let's also list our element N here. We have N as the set of elements that are days which contain 6 letters. If we quickly looked through our universe here, we'd also have Monday and Sunday. So we have all our lists of every set. Let's see if we can find the complement of our set S as listed. We have our set S and we have our universal set. The complement of set S will be the elements present within our universe here that are not present in our given set S. Therefore, S prime, or the complement of S, would be, we have Tuesday, Wednesday, Thursday, Saturday, and Sunday listed in the set S. Therefore, the remaining days of the week, which are the elements of our universe that are not present within S, would be Monday and Friday. The complement of our set S is a set that has as its elements Monday and Friday. Next, let's find the complement of our set N. The complement of our set N would be a set that has elements present in the universe here that are not present in our given set N. Our set N has as element Friday, Monday, and Sunday. The set N prime has as its element Tuesday, Wednesday, Thursday, and Saturday. And that's the complement of our set N. It's a set that has elements Tuesday, Wednesday, Thursday, and Saturday. Now, we need to take note to know that the cardinalities of a set and its complement together equals the cardinality of our universe. Let's illustrate with a typical example. If we have a universal set that has elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have a set N that has as its element 1, 2, 3, and 4. The cardinality of our set N, of course, is, if we did a count of its unique elements, we would have 1, 2, 3, and 4. While the complement of our set N is a set that has the elements present in our universal set but not in our given set. If we did a comparison, that set that has such elements would be a set that has elements 5, 6, 7, 8, 9, and 10. The cardinality, therefore, of the complement of our set N is a count of the unique elements within our complement here. Let's do a count. 1, 2, 3, 4, 5, 6, 6. Now, the sum of our cardinalities is 4 and 6, which of course would give us 10. The cardinality of our universe, on the other hand, is a count of the unique elements within our universe. Let's quickly do a count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 again. So again, our statement here is very much correct, that the cardinalities of a set and its complement together equal the cardinality of the universe. In summary, we've learned that there are properties of sets, and two major properties we learned today are cardinality, which we said is the number of unique elements that are within a given set, and we also learned about the complement. We said the complement of a set is the number of unique elements within the universe that are not present within a given set. And with that, we've come to the end of our class for today. I sure had a nice time. I hope you had a great time too. Till I see you next time, bye for now.